Hi students. So in this video we are going to discuss about total internal reflection. This is the last part of the 6th unit. Already in this unit we discussed about what is meant by light, what is meant by reflection of light. Then we discussed about a spherical mirror. In spherical mirror, concave mirror, what is meant by concave mirror, how the images are formed in concave mirror. And then last class we discussed about convex mirror, what is meant by convex mirror, how the images are formed in convex mirror. And then we discussed about what are the uses of concave mirror and convex mirror. And then we discussed about the mirror equation, lateral magnification and refractive index of the medium. Okay, so these are the important parts in this lesson we discussed. So finally we are going to discuss about the important question, that is total internal reflection. So what is meant by total internal reflection? When light travel from denser medium into rarer medium, it gets refracted away from the normal. Already we know that. We know the conditions we discussed last class. When the light travel from the denser medium to rarer medium, it gets refracted away from the normal. While the angle of incidence in the denser medium increases, the angle of refraction also increases. The angle of refraction is also increases because it is away from the normal line. It is away from the normal line means here the angle of incidence in the denser medium is increases, means the angle of refraction is also increases, and it is reaches at maximum values r is equal to 90 degree for the particular value. The angle of incidence is the critical angle. Okay, the angle of incidence is called a critical angle. The angle of incidence at which the angle of refraction is 90 degree is called critical angle. So it is a definition for the critical angle. It is important. 2 more question. What is in the critical angle? The angle of incidence at which the angle of refraction is 90 degree. How the angle of refraction is 90 degree? Listen to me. Here this is a denser medium, this is a rarer medium. The light is traveled from the denser medium to rarer medium, means it is away from the normal. So here you are increasing the angle of incidence. Whenever the angle of incidence is increases, means angle of refraction is increases at a particular values. Here the angle of refraction is also 90 degree, that is r is equal to 90 degree. Listen me. Okay, so this is angle of incidence. Here the angle of incidence is increases. Whenever the angle of incidence is increases, means the angle of refraction is also increases. Okay, so at a particular level the angle of refraction is r is equal to 90 degree. R is equal to 90 degree means what is the meaning? Here that a refracted ray, it is also passing along the plane. The refracted ray is passing along the plane. Okay, so from this what is the meaning for critical angle? Critical angle means it is the angle of incidence. It is the angle of incidence at which the angle of refraction is 90 degree. That is the angle of incidence at which the angle of refraction is 90 degree is called a critical angle. Students, I hope you understood that at this angle the refracted ray traces the surface of separation between the two media. Okay, that is a plane I told. Okay, so at this angle this refracted ray is passes, the ray traces the surface of separation between the two media. Okay, so when the angle of incidence exceeds the values of critical angle, the refracted ray is not possible. So further the angle of incidence is increases. Here in this values, here it is retraces on the plane. Further the angle of incidence is increases, means here it is not refracted. So the ray is totally reflected back into the medium. Further the angle of incidence is increases, means this ray is not possible to pass through the medium. So here it is reflected because the angle of refraction is increases. The angle of refraction is greater than 90 degree. At this point the angle of refraction is 90 degree. Further the angle of incidence is increases, means here it is has the values greater than 90 degree. So the ray is totally reflected back to the same medium. This is called total internal reflection. Okay students, so condition to achieve total internal reflection. In order to achieve the total internal reflection, we need to follow the following conditions. The first one, light must travel from denser medium to rarer medium. Because when the light is transferred from the denser medium to rarer medium, at the time only the refracted ray is away from the normal, so the light must travel from the denser medium to rarer medium. Example, from water to air medium. Next, the angle of incidence inside the denser medium must be greater than the angle of critical. Okay, so the angle of incidence inside the denser medium must be greater than the critical angle. Next one is total internal reflection in nature. Total internal reflection in nature. Okay, the first one, that is mirage. On hot summer days, batch of water may be on the road. This is an illusion. In summer, the air near the ground becomes hotter than the air at a higher level. Hotter air is less dense and has smaller refractive index than the cooler air. Thus, a ray of light bent away from the normal and undergoes total internal reflection. The total internal reflection is the main cause for the spectacular brilliance of diamonds and twinkling of stars. Okay, this is the applications of the total internal reflection. The total internal reflection is the main cause for the spectacular brilliance of diamonds and twinkling of stars. So, optical mirror. Optical mirrors are bundles of high quality composite glass or quartz fiber. Each fiber consists of a core and cladding. The refractive index of the material of the core is higher than the refractive index of the cladding. Optical fiber work on the phenomena of total internal reflection. When a signal in the form of light is directed at one end of the fiber at a suitable angle, it undergoes repeated total internal reflection along the length of the fiber and finally comes out at the other end. Okay, so the fiber, optical fiber, its work based on the total internal reflection. How it is works means, when a signal in the form of light is directed at one end of the fiber at a suitable angle, it undergoes repeated total internal reflection along the length of the fiber like this. Okay, it is reflected like this and it is reached the other end. Okay, so the length of the fiber and finally comes out at the other end. Students, uses of optical fiber. The optical fiber are extensively used for transmitting audio and video signals through long distance. Moreover, due to their flexible nature, optical fiber enable physicians to look and work inside the body through tiny incisions without having to perform surgery. Okay, so without surgery to cure the disease, the physicians to look and work inside the body through tiny incisions without having to perform surgery. These are the application of the optical fiber. Thank you, students.
Uses of bases. Uses of bases. Similar to acids, bases are also very important in our life, and bases have got their own importance, their own uses. Sodium hydroxide is used in the manufacture of soap. Soap manufacturing involves sodium hydroxide base. Magnesium hydroxide. This is a base which is used in curing stomach disorder. Stomach disorder. We are having a Gelusil tonic that is taken for ulcer. Gelusil tonic has got magnesium hydroxide base in it. In our stomach, we know that hydrochloric acid is secreted. So when large amount of hydrochloric acid is secreted, the walls of our stomach become wounded, and those wounds are called as ulcers. And in order to clear those wounds and get rid of those wounds, a base is allowed to react with acid so that neutralization reaction may take place. So the base used for stomach disorders is magnesium hydroxide. Next one is calcium hydroxide. Calcium hydroxide, it is used in whitewashing buildings. Whitewashing buildings. Whitewashing buildings is done with the help of the base calcium hydroxide. Okay. Then ammonium hydroxide, NH4OH. NH4OH. Ammonium hydroxide, children. Its name is ammonium. This may be new to you. Ammonium hydroxide. So ammonium hydroxide has got the formula NH4OH. This is used in removing the grease stains from clothes. It is used for removing grease from clothes. These are the very important uses of bases. Bases, many bases are there. Sodium hydroxide is used in the manufacture of soap. Magnesium hydroxide is used as a cure for stomach disorder. Calcium hydroxide is used for whitewashing buildings. Ammonium hydroxide is used for removing the grease stains from clothes. Now we are going to learn tests for acids and bases. Okay, tests for acids and bases. An acid and base, they are differentiated and distinguished with the help of indicators. In our vehicles we have indicator, no? In our vehicles, the indicator indicates the direction in which the vehicle is moving. Similarly, here in chemistry, we have got indicators, chemicals. Indicators here are nothing but chemicals, and these chemicals help us to indicate the chemical present in a compound. Whether the compound is acidic in nature, whether it is basic in nature, whether the reaction is reached its end, or the reaction has to be continued. So all these things are told by an indicator in chemistry. Here we have got litmus paper, phenolphthalein, methyl orange, and these are very familiar indicators to indicate the presence of acid and base by color change. Okay. See, first one is litmus paper. A litmus paper with acid changes from blue to red. Blue to red. Whereas when a base reacts with a litmus paper, it changes from red to blue. Next indicator is phenolphthalein. 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 Then another one indicator, it is methyl orange. These are indicators which indicate the presence of acids and bases by color changes. Phenolphthalein is colorless with acid, whereas it is pink with base. When a base, see, that is, to a base, if a phenolphthalein indicator is added, it gives pink color. Whereas to an acid, if a phenolphthalein indicator is added in drops, it is colorless. No change is observed. Okay. Then methyl orange. Methyl orange gives pink color with acid and yellow color with base. Okay, children. So these are tests for acids and bases with the help of indicators. The indicators here we have used are litmus paper, phenolphthalein and methyl orange. Litmus paper, with litmus paper, acid changes a blue litmus paper to red, whereas a base changes a red litmus paper to blue. Phenolphthalein gives no color with acid, whereas with base it gives pink color. Methyl orange indicator, it gives pink color with acid and yellow color with base.